Lesson 86, volume of pyramids and cones. First off, let's look at what volume is. Volume is just the amount of space an object takes up. So you're looking at three dimensions, the length, the width, and the height. And we label them with cubic units. To the right, you see two solids, but inside each solid, the top one, a cube, we have a pyramid, and below we have a cylinder, and inside the cylinder there's a cone. To find the volume of a pyramid, it would be 1/3 times the base, area of the base, times the height. So the volume of a cube is actually 3 times the volume of a pyramid. That's why it's 1/3, because the pyramid is only 1/3 of the volume of the whole cube. And for the volume of a cone, the cone is 1/3 the volume, or 1/3 of the volume of a cylinder. So you would take 1/3 times pi times radius squared times the height, because pi times radius squared times the height would be the volume of a cylinder. So 1/3 of that would be the volume of a cone. We're going to make use of those two formulas today, solving our problems. Our first one, Aiden built 2 cones out of sand on the beach. The diameter of the smaller cone is 6 inches, and its height is 5 inches. The diameter of the larger cone is 12 inches, and its height is 10 inches. How many cubic inches of sand did Aiden use for each cone? And down below, here it says express pi as pi. We're going to do that for both of these. So first off, finding how many cubic inches of sand did Aiden use for each cone. So volume equals 1/3 pi radius squared times the height. So for the first one, we have the smaller one has a diameter of 6 inches. So the radius would be 3. So I have 1/3 times 3 squared times the height, which is 5. So now I have 1/3 times 9 times 5. And I can simplify here. 9 divided by 3 is 3. So I would have 15 pi cubic inches for the smaller one. And for the larger one, we would have 1/3. And the diameter is 12, so the radius has to be 6. So 6 squared times the height, which is 10. And then we have pi as well. So 1/3 times 36 times 10 times pi. I can simplify here. 36 divided by 3 is 12. 12 times 10 is 120. So we got 120 pi. So how many cubic inches of sand? We would have 15 pi cubic inches, and we would have 120 pi cubic inches. The last question is, how many times greater is the volume of the larger cone than the volume of the smaller cone? So for that one, we would do 120 pi divided by 15 pi. And that would give us an answer of 8. So it is 8 times larger. Next one, the diameter of the base of the cone is 20 inches. The height is 21 inches. What is the volume of the cone? Express the answer in terms of pi. And again, round it to the nearest cubic inch. So 1/3 times the radius. Radius squared, so the radius would be 10. So 10 squared times pi times the height, which is 21. So now we have 100. 10 squared is 100. 100 times 21 would give us 2100. Divide that by 3, that would give us 700. So we would have 700 pi. and this would be cubic inches. That would be our answer in terms of pi. If I take that 700 and multiply that by 3.14, we would get an answer of 2,198 cubic inches. That would be to the nearest cubic inch. These would be our two answers for that problem. The next one, a party hat arrived in a cylindrical container in which it fit perfectly. If the volume of the container is 99 cubic inches, what is the volume of the cone-shaped hat? So volume equals 1/3 pi radius squared times the height. Since at the very beginning we said that the volume of a cylinder is 3 times the volume of the cone. Here they're giving us the volume of a cone, the volume of the cylinder. The volume of the cylinder is 99. If that is 3 times the volume of the cone, what is the volume of the cone? I would just have to divide that by 3, or here it's 1/3 times the volume of the cone, of the cylinder. So 99 divided by 3 would give us 33 cubic inches. And this would be the volume of the cone-shaped hat. Moving on to pyramids. Find the volume of this square pyramid. So we would have the formula V equals 1/3 times the base times the height. And the B just means the area of the base. And for a pyramid, the base is always going to be a square. So take the 1/3 times the base, it's 90 by 90. So 90 by 90 would be 8,100 times the height is 50. And I can simplify here. 8,100 divided by 3 gives us 2,700, and 2,700 times 50 would give us a volume of 135,000, and this would be cubic centimeters. Next one, a triangular pyramid is shown. The area of the base is 36 times the square root of 3 units. Find its height is 10 units. What's its volume? So I would take volume equals 1/3 times the area of the base times the height. They told us the area of the base is 36.3, or 36 times square root of 3. So I'm going to put that in for B. And then the height is 10. So now we can put all those together to simplify. So here we would do 3 times 10, which is 30. And then we would have 30 times 36. Actually, it would be 36 divided by 3, which is 12. 12 times 10 is 120. And then we have the square root of 3. We will keep the radical in there. So this would be cubic units. So we won't need to put in the square root of 3. Just put that as the square root of 3 in your answer. Next one, find the volume of a pyramid with dimensions 1/10 of the pyramid shown. So the pyramid is to the right here, the same one as we had in our previous problem. So the dimensions are 1/10 of it. So 1/10, that means these would be 9. So I'm just dividing 90 and 10. This would be the height of 5. So 1/3 times 9 times 9 is 81 times the height, which is 5. So again, simplify, divide a 3 here and get 1, divide a 3 here and get 27. 27 times 5 would give us an answer of 135 cubic centimeters. Now the volume of the smaller pyramid is what fraction of the volume of the pyramid in sample 2? So we had The smaller one is 135, and the larger one was 135,000. So if we do 135 divided by 135,000, we would get an answer of 0.001, but it says what fractional part would that be? So this is tenths, hundredths, thousandths. So we would say 1/1000th of a fraction. And our last one here. Pyramid of a hexagonal base of a pyramid is 18 square root of 3. The height of the pyramid is 112. What is the volume? So I take my 1/3 times the area of the base, which is 18 square root of 3, times the height, which is 112. And I can simplify here, divide a 3 here, divide a 3 here, and get 6. 6 times 112 gives us 672 times the square root of 3, and our units would just be units cubed. Next one, using a 12-inch cube of clay, Lucian makes a 12-inch high pyramid with a 12-inch square base. What is the volume of the pyramid? So we have a diagram down below. So the height is going to be 12. The base is 12 by 12. So we have 1/3 times 144 times 12. 144 divided by 3 is 48. And then 48 times 12 will give us a volume of 576, and this would be cubic inches. Does Lucian have enough clay to make another pyramid of the same size? So if we were to find the volume of the whole cube, that would be 12 times 12 times 12, which would be 1,728. That would be cubic inches. He used 576 for one of them. If I were to take this volume and divide that by how much one of them covers up, 576, I would have an answer of 3. So does Lucian have enough to make another one? Yes, he would actually have enough to make 2 more. So he has enough to make three pyramids out of that one clay. So that is our lesson today on volume of pyramids and cones.